everybody! In this video we're going to be talking about a tool that we can use for one very specific class of polynomials. And that tool is going to be called using the difference of squares. So you'll see we have typed out here that a squared minus b squared, that's going to be the same as the term a plus b times the term a minus b. So let's start out by convincing ourselves that this is actually true. That this is something that happens. So let's go ahead and actually start with the right side of that rule. I'm going to start with that a plus b times that a minus b. And we can go ahead and multiply this out. Right, so let's start by using that distributive property, distribute that a plus b to both of those terms. So I'll have a plus b times that a, and then I'll have a plus b times that negative b. Using the distributive property again, I'll get out an a squared plus ab from the left side, and I'll get a negative ab minus a b squared from that right side. And you'll actually notice, right, if I have that positive ab and that negative ab, I add them together, they'll cancel out. All I'll be left with is that a squared minus b squared. So what we're going to be doing in practice, right, since we're trying to get from things in the more standard form to things in factored form, is that we're going to be trying to find a difference of squares to be able to use this to get it back out into that factored form. So let's look at a few examples. Let's start with x squared minus 49. So it doesn't quite exactly fit that form, but it's super close, right? I have that x squared part, and I can actually write 49 as a square. Right? You might remember that 49 is actually 7 squared. And now I have that exact form. I have something squared minus something else squared. So I can use that formula. So I'm going to do x plus 7, and I'll also get that x minus 7. And the order here is important, right? Since it started with x squared minus 7 squared, that second term in my factored form is going to be x minus 7. I'm going to preserve that order. Okay, let's look at a couple more examples. We could also see negative 1 plus y squared. Right, it doesn't quite look like a difference of squares, just like that first one. We're almost there. I've got a square, but I'm not quite subtracting them. But I could just rearrange the order of these, right? I could do that y squared first and then minus 1. So now I have a difference. I was looking for that part. And then something super useful about 1 is that 1 squared is itself again, right? So I could rewrite that 1 as a 1 squared. And now I can apply that formula. Now that I have that precise form, something squared minus something else squared, I can go through and rewrite that y squared minus 1 squared as y plus 1 times y minus 1. Let's go ahead and do one more example. For this last one, we'll look at 16x squared minus 9y to the 4th. So again, we need to get something that looks like one term completely squared minus another term completely squared. So in order to get this term on the left to be completely squared, we have to be able to have that square on both of the terms, not just the x. And now the square is only on x. But if we think about the square root of 16, right, 16 is the same as 4 squared, we can actually rewrite 16x squared as 4x in parentheses, and then that whole thing squared. Right, if we fall back on our rules of exponents, we know we could distribute that power of 2 onto the x and the 4. It would get us straight back to that 16x squared we started with. Okay, and we want to do something similar for that 9y to the 4th. So we need something squared. Well, something squared to get to 9, that would just be a 3. Something squared to get that y to the 4th would be a y squared. Right? And again, we could fall back on those exponent rules to see that if I gave that square back to both of those things in that product, get straight back to that 9y to the 4th. All right, and now I have that precise form again from my formula. I have one thing in parentheses squared minus one other thing in parentheses squared. So now I'm allowed to use it. So here I'm going to do 4x plus 3y squared, one set of parentheses, and I'll do that 4x minus 3y squared in the next set. That's how you apply that difference of squares rule.